Good afternoon. This is your host, Michael Holt, with the Half Hour with Premier Power. I'm owner-operator of PremierPowerInc.com. I'm an electrical service contractor here in Lake County, and we are on week number 3 of our information station. I have a couple of people with me I want to introduce to you. First off, we have Mike Holt, which is my father. He is a world-renowned electrical expert and business management gentleman. And Mike, want to go ahead and introduce yourself?
All right, thank you, son. My name is Mike Holt, and if you have any real heavy technical electrical questions, that's what I'm serving here. My son, Michael, is the electrical contractor, and if you want to know more about what I do, you can go to mikeholt.com. And
we also have with us Belinda Pinto Holt, which is my sister. She works for Mike Holt Enterprises, and she's involved in the electrical industry. And Belinda, go ahead and introduce and tell us about your role with us and how you fit into this whole thing.
Well, good afternoon. I'm excited to be here. Thank you for the invite again.
Absolutely.
I'm just here to represent the consumer and to ask the kinds of questions that people might have out in the county. And if anybody has a particular question, they can give us a call here and ask their questions to either you, Michael, or you, Mike. They can call my 790 AM 352-787-9523. And I believe, Michael, you were giving away a home electrical inspection for the callers?
Yes, whoever can call in today, we're going to give away a free electrical home safety check. So whoever calls in, take advantage of it. Give us a call. We'd love to visit with you. We love people. We love electricity.
And that's my 790 AM 352-787-9523. Give us a call.
And also, if you're not comfortable calling in, I know it's a little scary, go ahead and maybe send me a text message on my phone, 352-978-7015. It's a little bit less intrusive and a little bit behind the curtain, so please feel free.
all right, let's go ahead and start our little technical discussion and do a quick little review. The first week we covered home safety inspections. So if you didn't hear
and that was home safety electrical inspections.
That's a good point. Home safety electrical inspections. And if you didn't get that, you go to PremierPowerInc.com. There's a link called radio, and you can get the first audio of that one. Last week we covered GFCIs in the second week, and that's also an important one, talking about electrical safety as it relates to where there's water. Son, you going to say something?
No, I have nothing to come up, but home safety checks. Last week we did one for your house, Father, and we also did one for my sister's house, Brittany. We did one a couple of days ago, so we're in the middle of that right now, working on it. A couple of things came up. Some outlets aren't working, and we have to revisit, and it's a little bit more detailed.
And we talked about that on week 2 about GFCIs, that after the home inspection done at my house, we actually had, 5 GFCIs that failed?
No.
I want to interrupt for one quick minute. For those of you that, the audience that might not have been a part of last week, let me tell you what I took away from last week's show. This is what I learned. GFCIs are the receptacles that we plug in our cords in places that there are wet areas, like the bathrooms, the kitchens, I think you said swimming pool areas, outdoors.
And garages.
I didn't realize, I didn't pick up on that. And garages. So GFCIs are those special receptacles. And what I understood from last week's show is that the purpose of these special receptacles and the purpose of having them checked is because if they're not working, there is a risk for shock.
That's right. They protect persons and property from electrical shock. Now, you're getting really experienced, and maybe I can hire you as an apprentice or an electrician. I think it'd be great, and another good, warm, for the customer, a nice woman in there. So
if I keep on this show, I'm going to learn everything I need to know.
You sure are.
Now, the GFCIs, GFCI is an electronic device.
Okay.
And it doesn't have to be in the receptacle. It could be in the breaker. And if you go to Home Depot or you go to Lowe's or any Ace Hardware, any show, if you get a chance, go to the electrical section, and you'll see extension cords have GFCIs.
Oh, I didn't realize that.
Yeah, because, see, somebody might live in a house, and there is no GFCIs because it was built prior to the code requiring it, and you're outside, you have water conditions.
And that was about 30 years ago.
It started in 1971. Actually, 1968 is when it started. So I don't want to get too much time on the GFCIs because that was last week's show. I want you to listen to last week's audio. Go to PremierPowerInc.com. Click on the radio link into more details. But one of the things that maybe we talked about was the high failure rate of GFCIs. There are safety devices protect you against shock. But in my house, I think we had 5 devices that had failed.
No, we actually tested 5 devices.
Oh, we tested 5.
Out of the 5, 3 of them failed.
Okay. And 2 of them were receptacles.
All 3 of them were receptacle type. Oh, I'm sorry. You're right. Actually, we tested 5 receptacles and 1 GFCI breaker, and that GF5 breaker failed. So out of the 5 receptacles, 3 GFCI type receptacles failed and 1 GFCI type breaker failed.
Now let's talk about the reason for electronic failures. And today's discussion, I think, is going to talk about magnetism.
Okay.
It's going to talk about lightning and what lightning does to electronic equipment. We mentioned briefly last week on GFCIs that there was a high failure rate. And if anybody wants to know, well, what's a high failure rate? It's about 1 out of 8 fail electronically. And I think, Belinda, you even asked me, I forgot who asked me this week, well, when they fail, what happens? When they fail energized. Meaning that if your GFCI had failed, you wouldn't know it failed.
Because the electricity is still working.
The electricity is still working.
But the protection part of it doesn't work.
Exactly. And
so it's the danger is right there.
And that's why week 1 we talked about the home inspection and what Michael did at my house, because I just assumed they all worked.
Right.
I didn't pay attention.
You're the electrical expert.
I'm the electrical expert, like the shoemaker. How's that with what do we call the cobbler or something like that? Whatever. So anyways, so Michael came over, and then we found, okay, they failed. So now he's fixing them, and then you went to Brittany's house, right? How are the GFCIs in her house?
They're working fine. Everything's taken care of. There's a whole other thing going on there with an open neutral,
but she had old wiring. This is the old.
Brittany's house is built before the 50s. It's really old wiring, yes, and it's 2-wire circuits.
Okay,
so that's an interesting thing. So when you're coming out and doing home safety electrical inspections, you're not just checking GFCIs. You're checking all types of things, different wiring issues and stuff like that.
On the safety check, we're checking the panel, visually, looking at it, is it physically, fit? The receptacles, are they all secure? The overcurrent protection, make sure they're tripping properly.
You mean breakers and fuses?
I'm sorry, the breakers and fuses. Yep, making sure all the panels, all the receptacles, all the outlets, the smoke detectors, the lights, making sure everything is working properly and testing it. With older wiring, there's a job that I did yesterday, and this older house has probably 1950s 2-wire circuits, and the customer, or the homeowner rather, replaced all his receptacles, and he put 3-prong receptacles on 2-wire circuits. And there's another requirement for GFCI also involved in,
Well, let me explain that. What Michael's saying is that, prior to the 60s, there was no ground wire. And I know non-technical people don't know what it is, but I mean, even a non-technical person knows something about ground.
What is ground?
I mean, I can't answer it that way.
What's the purpose of it?
Okay. I don't know if I can even answer that for you. I'm just saying that when you look at receptacles, you'll see that there's 3 openings.
Okay.
One is a little smaller, vertical, than the other. The smaller one is a hot wire. So if you look at a receptacle, you'll see, okay, there's 2 vertical ones. The smaller side, which is, I think, on the right side, if the ground is down, that's the hot wire. The vertical on the left side, that's your white wire. It's called the neutral. And the one in the center is your ground wire. Now, a ground terminal, rather. These are terminals. Now, on the other side of that receptacle, you should have a black wire, let's say on the hot. You should have a white wire on the neutral, and there should be a green wire or a bare wire on the ground. Now, to answer your question, the purpose of the ground wire is that if you had a failure of the equipment and the hot wire, let's say, touched the frame of the refrigerator, and all of a sudden now, if you take a hot wire to a metal refrigerator, the refrigerator is energized.
I see. So you could get shocked, and you could even become electrocuted.
Well, yeah, you could be electrocuted, which means you die.
Right.
So if the refrigerator is energized and you're standing barefoot, right, or you touch your sink and then you touch your refrigerator.
Then the path goes through you.
Exactly. See, electricity leaves the power supply and it goes in a circuit, which means it leaves and it comes right back to the beginning source. Now, we would prefer that it leaves on the hot wire and return back on the neutral, the white wire. In other words, that's how it goes out on the hot and it comes back. It really doesn't go out on the hot. It's alternating current. It actually goes back both ways. So let's just say it goes out on the hot and returns on the neutral.
Right.
Well, if there's a failure to the refrigerator, it should then go to the ground wire, and the ground wire is run back over to the source.
So it's like a communication device?
Well, it
tells them there's a problem?
No, it actually just goes so fast because it's a ground fault.
And that ground wire is attached to the piece of equipment, so the whole piece of equipment is a ground.
The equipment is energized, the current travels back to the source, and then that's when you trip your breaker.
Okay.
So in order to trip the breaker under a fault, you need a ground wire. And we'll talk a little bit more about that when we get back.
And if you have questions, you can call us at My 790 AM, 352-787-9523. It's a great time to call us now.
Power. This is Michael Holt. I wanted to thank you again for listening to the show. I think we might have a caller that came in. Is that right, Mike?
Okay.
Hi, hello. This is Michael with Premier. How can I help you?
My question is, if I have an older home and it doesn't have the 3 prongs, which means I guess that it's not grounded, can I still have GFCI, or does none of that, do I have to have everything rewired in order to get the GFCI by the thing?
Okay, that's a great question. And let me just back it up a little bit. The way electricity works, it leaves the power supply. It stays in insulated conductors. It goes through the equipment with insulated conductors. It returns back on the white wire with insulated conductors, and everybody's safe. That's 2 wires. If a wire goes out and then it faults, let's say to the refrigerator, and it's a 2-wire house and there's no ground, then the refrigerator will be energized and there is no way to trip the breaker. That's the purpose of the ground wire, is to trip the breaker in the event of a fault. Now, to answer your direct question, a GFCI, which we talked about yesterday, it's very difficult to explain this in a radio, and then, of course, the non-technical people. A GFCI does this. Remember how I said the current leaves on the hot wire, returns back on the neutral wire? It goes out and comes back? With the way it works, the electricity works, the exact same number of electrons leave, return. And when you know that, then you can put an electronic device around both wires, and you can measure, well, how much left and how much returned. If you have a refrigerator that's plugged in and it draws in, let's say, 1 unit of measurement, and it goes out, then 1 has to come back. But if for some reason there is no ground wire, your refrigerator is energized, you touch your refrigerator, you touch your sink, that means that some of the electrons left the power supply and not all of them return back on the neutral, and the GFCI senses the imbalance between the hot and the neutral. And to answer your question, will a GFCI work if you have a 2-wire circuit? And the answer is yes. And that is the critical part of GFCIs, particularly in all older homes that have 2-wire receptacles. And Michael, you were talking about yesterday, they had 2-wire receptacles, and this is a real danger, and this is a great question. The danger is this. You have 2-wire receptacles. Somebody comes in and says, oh, you need to plug these things in. It requires a 3-prong thing because 2 doesn't work because you got a new appliance. No problem. They change the receptacle to a 3-wire receptacle, and since there's no ground, then they don't connect to ground. So they take 2 wires onto a 3-wire receptacle, but you, the homeowner, you don't even know that. You just know that you plug something in and you just assume that whatever it is, it's safe. Well, it's not safe, because if there's a fault, you will energize everything, and there's no GFCI. So what the National Electrical Code says is this. If you have a 2-wire receptacle, anytime you do any remodeling, you have to replace it with a 2-wire receptacle, because then it's obviously clear. What? There is no ground. Belinda, you agree with that?
Mm-hmm.
Yes, but real fast before we get ahead, did we answer the caller's question?
I'm finishing it.
Okay.
So a 2-wire receptacle can be replaced with a 2-wire receptacle, and everybody knows there's no ground. A 2-wire receptacle is permitted to be replaced with a 3-wire receptacle and not connect to ground, but only if that receptacle is protected by a GFCI protection device.
So there could be...
Is it...
Go ahead. Go ahead. Ask your question.
Is it protected? In a hardware store, you can buy the orange extension cords that are 2-prong at the one end, but on the other end you can plug in a 3-prong product?
No, they don't. They don't.
They sell those devices. I know what you're talking about. They have a little 2-prong, and then it opens up where you can put a 3 to it. So they have a little.
You mean like an adapter?
Yes. So then, is it protected, or is that just
no? That's
dangerous?
very, very dangerous. That's somebody saying, okay, I need an appliance that requires a ground wire, and since it can't fit into my receptacles because my receptacle is only 2-wire, then they get what is called a cheater or an adapter. Now the danger there is, yeah, you got the energized circuit. But the danger is there's no way to be protected against electric shock in the event of a fault.
And pretty much that 3rd prong, the ground, is just floating. It's just
right. It's just
nowhere.
a mechanical device to be able to plug in a 3 into 2. So the answer to your question, which you really need, if you have any 2-wire circuits in your house and you're going to replace the receptacles, and you want to use 3-wire receptacles because it's convenient, because today's appliances require 3-wire attachments often, then that receptacle has to be protected by a GFCI protection device. and it really needs to be installed by an electrical contractor.
Licensed.
A licensed electrical contractor.
So that if my house is older than 1971, I should definitely have it inspected?
Well, yeah. I mean, for sure. That's 40 years ago.
Right.
Yeah.
So that's something that becomes top priority.
So, well, if your house is old, if your house is if you moved into a house that wasn't your original house, you don't know what might have happened, and this house could be 5 years old, and it could be 20 years old. So the best thing is to have, it isn't that expensive, just a simple, quick 1 hour, a quick review of your home to make sure that the grounds and all the receptacles are working, that the GFCIs are working, and if for some reason you don't have all the protection you need, then you get a report saying, hey, you should do this and you should do that.
We talked a couple weeks ago, and Linda, I don't mean to cut you off, but we talked a couple weeks ago, and Belinda brought up some questions. We asked, well, how do you know when you should have a home inspection? When do you require one? When do you request one? And I think a good point would be is if your house is older than an older house back in the 70s, that it'd be a good idea just to come in there and do a little brief inspection.
If it's to me, I think if you've never had your home inspected, and it's for sure at least 10 years or older. And if you're in the 50s and 70s and 80s and 90s, 100%. All right. I appreciate that call.
Thank you very much.
And you'll be put into the drawing for the free home electrical inspection.
You're right. And Linda, thank you for calling in the time.
Thank you. Bye-bye.
And if anybody else has a question, that number is 352-787-9523. And I have a question.
Okay.
Oh, right.
One of the things you talked about is the 2-prong and the 3-prong. So it sounds like we used to have 2 prongs for a lot of things. And so that's a really interesting question. Why do some appliances have 2 prongs and
Great
some
question.
appliances have 3 prongs? Is it that those appliances are more dangerous?
All right, great question. Here's the history of why do you have 2 wire receptacles or 2-prong receptacles in the first place, right? I mean, why did we go to 3 when we already had 2 for maybe about 70 years? It was always 2 wire receptacles. The reason being is because houses years ago did not have metal parts. They were made out of wood, a drywall, wood flooring. So the old houses up north, the 2-wire receptacle is okay. But once they started getting metal appliances, metal equipment, other things get it connected, and then they start seeing a history, people are getting killed. Why are they getting killed? Well, because appliances are failing. Energize the refrigerator. Somebody touched the refrigerator. Somebody touched a sink. All of a sudden, they're dying. So when they found the history of people dying, they realized we need to protect people. So they started running ground wires on all the receptacles and all the equipment. You think, okay, that's all the problem. No, that wasn't the problem solver. The problem is this. People are still dying. Because, see, the ground wire only works if the fault goes directly to the case, and the case is connected to the ground wire, okay? What about if you touch something that's not grounded? You just touch something that has no ground wire at all, the 2-wire receptacles. That's where GFCIs come in. So GFCIs will protect you without a ground.
But what I was asking was the actual prongs themselves.
Okay, why
do some
question.
appliances have 2 prongs and some appliances have 3 prongs?
Go to your kitchen.
And like the one in the laundry room has a totally different prong.
Well, that's only because it's a different configuration because of ampere. But let me talk about 2 to 3.
Right, because that was a good point that she brought up, that sometimes you don't need 3 prongs.
Right.
It's only on certain items you do. So as she asked that, I thought, well, why are there 2 and 3 prong appliance endings? I don't know what those are called, the prongs that go in.
If you go into your kitchen, you look at your toaster, you'll see that the toaster generally, at least in the past, was only 2-wire.
Mine is 2 prongs.
2-wire. Exactly, 2 prongs inside there. And it's a matter of product. A lot of times when something is made out of all plastic, it's called double insulated. The only reason you have a ground wire because there's something metal and you have electrical, right? Mm-hmm. If there's no electrical connected to it, then you wouldn't have a ground wire. But if you have electrical and you have a metal enclosure, then you need a ground wire. But even that doesn't mean. Now the problem with the reason, okay, well, why don't you have a ground wire on the toaster? Well, because if you put a toaster on, you see the red element? Mm-hmm. That's actually an energized conductor. It's hot, it's red, but it really is a conductor. It's energized.
So that's the electricity running
It's
through
exactly.
it?
So if you take a fork and you put a fork inside your toaster, on the element
Maybe
that's red.
Maybe not a very good idea.
Not a good idea because you're actually touching the hot wire.
Wow.
Which is 120 volts.
Which is 120 volts.
And that sounds like a lot.
Now, it's a big number. Now, the key is this. And the toaster is not grounded. The reason a toaster is not grounded because if you put the fork in there, then you'd have a short. because the case would be grounded and it would short out. And they're not looking for people to be shorting it all out. So they figure, okay, this appliance is a toaster. It goes installed where? Where does it get installed?
In the kitchen.
And the kitchen requires what type of protection?
GFCI
protection. And so it's a matter of all the pieces coming together. What's the application? What's the likelihood of GFCI? But if you're an old house that has no GFCI protection, or you have a GFCI action, remember the caller asked about home inspection? Well, my house is only 15 years old, and I had, 4 out of 6 GFCIs that failed. So it doesn't have to be an old house. It needs to be, inspected.
Well, I think we're closing up the show here today, so I want to thank you for taking the time to listen to us.
Man, it went fast.
It did go fast. It's too fast. If you have any questions or any concerns at all, please feel free to give me a call. My phone number is 352-978-7015. I'm almost always available. And thank you for the show, and have a great day.
All right, thank you.
Thank you, guys.